All right, guys, we're going to do 2-5 today. 2-5 is really the stuff we've been doing all along. It just looks a little bit different. The part is looking a little different messes with some people's heads, but you can kick butt and take names on this. Let's just rock it out. So this section we're solving for a variable. And what we've been doing up until now, we've typically had like, here's an X and everything else is numbers. Now we're going to be giving you several letters. But if you know what to do with the numbers, you do the same exact thing with the equations that have letters. You'll see where I'm going with that. Main thing, don't be afraid. These things can smell fear. Okay, first of all, I want to go back and give a couple of definitions. This is the less exciting part of the notes, but an equation is simply going to be something equals something. So you just have to have an equal sign and something on either side. So 5 equals 5 technically is an equation. X equals 4 is an equation. 3x plus 7 equals pi is an equation. You just have to have an equal sign and something on either side. A formula is a type of equation. A formula is going to be where you have one variable equals something. So of those ones that we had before, only one is going to be a formula because that's x equals something. But that's not the only possible thing. You could have like a y equals 3x plus 9 or something like that. Those two are both going to be formulas because it's just a single variable equals something. Technically, a formula is just an equation that is solved for a single variable. And we're going to be solving for single variables today, like it's our job. So, okay, so you've been doing this for 4 sections with numbers. Now you'll be moving letters. It may look harder, but it's basically the same as you've been doing. In some respects, if you get to a point and you get stuck, well, kind of pretend that they're numbers. See what you do with the numbers, and just do the same thing with the letters. Okay, so first example, we have this 7 equals x times 5. If you were given this with a solve for x, what would you do? Well, what was done to x? They multiplied by 5. So we're just going to divide by 5. I'm just going to kind of write that in here out of the way that we would divide by 5. Well, I want to give you something really similar. Let's say you're given the equation distance equals speed times time. So d equals s times t. And now they were to tell you solve for s. And I kind of want to point out, well, it's kind of in the same spot, that's in the same spot, that's in the same spot. Well, if we're solving for s, just like before, we'll do order of operations backwards, and there's really only one thing connected, so we don't need that. But if you look at how's the t connected to the s, it's connected by multiplication. You got that little dot right there. Well, what's the inverse of multiplication? It's division. So we could take, well, I'm going to divide by t, same as we would have divided by 5 right up here. If I divide one side by t, I have to divide the other side by t to keep it equal. And those t's drop out here on the right side. So I'm left with speed equals, or s equals, d divided by t. That's it. So it's really the same type of thing as what we've been doing all along. You do the same thing with the letters as what you do with the numbers. The difference is where before numbers, sometimes you'd be able to, once you divide, you'd be able to simplify it some. Here, you don't have to bother simplifying. Maybe it's easier. Okay, this is the next one. All right, we want to solve for C. And like we've been doing all along, we do order of operations. Please excuse my dear Aunt Sally, but solving for a variable, we go backwards. And again, if it's parentheses or grouping symbols, either one, that happens last. So we look at what was done to C. They did a couple things to C that messed it up good. First of all, they multiplied it by 9/5, and they added 32 to it. So we have to start with that plus 32. That's our first step to kind of unwrapping the gift. And, well, they added 32, so we subtract 32. So minus 32 from both sides. Like I was saying, sometimes it's maybe even easier because f minus 32, we can't say that's a certain number answer. We just write it the way it's written. So that left side becomes f minus 32. We can look at what's left on that right side. Well, the 32 is gone, but we still have this 9/5 C over there on that side. All right. Now we could take this and divide the whole thing by 9/5. We could do that. I wouldn't write this down. My problem is going to be this here. Once we do dividing both sides by 9/5, that gives us something really nasty looking on the left side. So this is going to be one of those rare situations where I'd take and actually do that in a couple steps. So I'm going to first, and you could do that and make it work out, but I'm going to say, let's do this. I'm going to do a times 5 right there. And that'll cancel out the 5 in the bottom of my equation. And I'm going to do a times 5 right here. But now where this messes some people is we have to do 5 times that whole side. So it's actually like we have parentheses in there. And that's going to cause us a little bit of work in a second. But on the right-hand side, my 5s are canceled out. So I just have 9c equals. I could rewrite this left-hand side the way it is. But I want a simplified answer. So I'm going to simplify that by actually doing the distributive right now. And that's going to give me 5 times a capital F, which would be Fahrenheit temperature, minus 5 times 32, which gives me 160. Or a positive 5 times a negative 32 gives me negative 160. So we end up with that there. All right. So we're simplified away. One step left to go. We have this 9 times c. So we want to divide both sides by 9 to simplify that. And when we have that done, we have c equals, and you could write it the way it is. If people weren't watching, I actually would flip it around the other way. I'd do c equals, and maybe I'll do that even though people are watching. So I'm going to do c equals, and I'm going to take and write this side here. I'm just going to kind of move it over there because that just makes me feel safe. If we could divide the 5 by 9 and the 160 by 9. If 5 and 160 are both divisible by 9, then I would go ahead and do it. In this case, neither one is, I think, so I am just going to write it the way it's written there. So I have 5f, so 5 times a capital F, minus 160, all divided by 9. So that's a pretty challenging one. I don't really think they're going to get that much worse than that. Although maybe since there's no numbers in this next one, it makes you feel a little bit uncomfortable. If we're multiplying variables, so variables are written alphabetically when the order doesn't matter. All right, so let's write that in. So variables are written alphabetically when order doesn't matter. And by that, I mean addition and multiplication. So you've, for years, probably gone over like the commutative property of addition, the commutative property of multiplication, that x plus y equals y plus x. Same thing's true with multiplication. So in this case, you'd want to do the x plus y. Or if you had multiplication, you'd want to do x times y is technically better than y times x. That's bad. So, okay. Whereas subtraction, you can't do that. If you have a y minus x, you can't change that to a x minus y. All right, special case coming right up. So solve for n when you have m divided by n equals p. Here's the problem. This is the wrong way. Please don't do this. People look at it and say, all right, I got to get rid of that m. Then they divide both sides by m, so divided by m. Then they cancel this out. You can do that. The problem is people go through and they say n equals. You can't do that. Getting rid of the m does get the m out of the numerator of the fraction, but n is still in the denominator. You'd be left with 1 over n equals p over m. And then you could take that and modify that to get your answer. But this is what the books tell you to do. This is what I think you'll be a much, much happier camper if you do this. So if you're ever solving for a variable in the denominator, I recommend this be your first step. That denominator is kind of like a trap. We want to get the n out of the denominator. And we do that by multiplying both sides by n. And when we do that, we kind of free up the n. It's not trapped in the denominator. I just have m equals. And going with what I said before, variables are written alphabetically when order doesn't matter. n comes before p in the alphabet, so we're going to do n times p. And then last step, once we're there as well, n is multiplied by p. We want to undo that. So I divide both sides by p. And when I do that, my p's cancel out here on the right. So n equals m over p. Or I would probably write it n equals m over p, just because that's the way we usually do it when solving for a variable. Put the solve for variable first. That's that. At this point, you could quit and be done, but I just can't help myself. I'm going to go back to that other way. I wouldn't write this. I suppose you could. If you were to do what we had done before, and say, all right, I'm going to divide by m, divide by m. The main problem is people just always say n equals, or usually say n equals, but it's 1 over n equals p over m. Well, you can do anything you want really to both sides as long as you do it to all of both sides. Well, I want it just to be n equals, so I'm going to flip this fraction. And when I do that, I get an n over 1, or just n equals. But I can't do that and have it be equals unless I do the exact same thing to both sides. So if I flip the right side, I have n equals m over p, which is the exact same answer as we had before. So that does work. Just if you were to go through and choose to do it the second way where you're dividing by m, you have to make sure that you don't take the n out of the denominator, that it's still down below. And then finish the problem from there. That's all. Knock 'em dead. You can do it.